Hey, another day with Dr. J. Today we're going to do the double angle and half angle formulas. Let's just jump right into it. So suppose I want to know what is sine of 2x. Sometimes we use theta or t or s or some other angle, but for this particular presentation, I'm just going to use x. Well, it turns out that we already have a formula for this. Because a double angle, 2x, is just the same as x plus x. So we can use the sum formula. So this really could have been done in the previous section, but we just saved it for its own day. So it's got its own day in the sun. So it also gives you a chance to review the formula. So you've got sine x, cosine x. These are like our alpha and beta, or S and T, or whatever we were calling it in the previous section. And then you have cosine x, sine x. This is the commutative property. So these are the same. These are like terms, so we can add them up. And that's our first formula. This is certainly going to be the easiest of all the double angle formulas. And in fact, all the formulas that we do today, this one is definitely the easiest one to remember. So the sine of 2x, or a double angle, is 2 times sine x cosine x. You want to see an example of that? Yeah, I better put it up here. I won't have enough room for it. Use the fact that sine of 120 degrees is radical 3 over 2. And cosine of 120 degrees is negative 1/2. I want you to use this double angle formula to find the sine of 240 degrees. So this is our x. This is our x. And this is our 2x, our double formula. So let's just do it. This will be 2 sine x is 120 times cosine 120. I gave you the sine and the cosine in this one. These are special angles that you probably already knew. So sine is radical 3 over 2. Cosine is negative 1/2. So this is, these 2's are going to cancel. This is going to be negative radical 3 over 2. See, the negative 1 is going to multiply by the radical 3, and typically we just put the negative on the top. Or you can put the negative out front like this here. I'm always afraid I'm going to lose it when I put it right there. So I put it right on top so that there's no question about the fact that I've got my negative there in my final answer. Okay. Now you probably already knew that. So the double angle formula is more of an academic exercise just to make sure that you understand the formula. Next, we're going to do cosine. And we're going to use the same strategy. 2x is the same as x plus x. So we can use the formula that we already have. Cosine x minus sine x sine x. So use the sum formula to find the double angle. Also gives you a chance to review the formulas from yesterday or from the day before yesterday. So when you add two angles, the sum of a cosine of a sum is the difference. It changes to a negative. So here you go, cosine squared minus sine squared. This one has two alternate versions. So you have the original version, and then you have these alternate versions by using the Pythagorean identity. So for this one, I can get rid of the cosine squared, and I can write that as 1 minus sine squared by replacing the cosine with 1 minus sine squared, and I get 1 minus 2 sine squared x. So there's another version. You call that version 2. And we have version 3. Now, you might not like that you get 3 different versions of the same formula. That only happens for cosine of the double angle. With sine, we typically just have the one version. But for version 3, do the same thing. Just get rid of the sine. So you get cosine squared x minus, and then you get rid of the sine, and you write it as 1 minus cosine squared. You distribute the negative, and then you combine the cosines, and you get 2 cosine squared minus 1. So for the double angle formula, you have 3 choices. To be honest with you, I've been telling you this the whole time. I only memorize version 1. I mean, if I had to memorize these for a test, I would memorize version 1. And then if I needed version 2 or 3, I could always grow them myself by planting this, because I'm never going to forget the Pythagorean identity, right? That would be like forgetting the Pythagorean theorem at your age. That's just not going to happen, right? All right, so let's try one. Use the fact that sine of pi over 4 is equal to we're not going to do pi over 4. We're going to do sine of 3 pi over 4 is radical 2 over 2. And cosine of 3 pi over 4 is negative radical 2 over 2. I want you to find cosine of 3 pi over 2. Now, this might not be easy to recognize, but 3 pi over 4 is 135 degrees. And 3 pi over 2 is 270 degrees. So you can clearly see that this is cosine of 2 times 3 pi over 4. Yeah. So this is your x. Yeah, 2x. So I'm using the double angle formula. Cosine squared 3 pi over 4 minus sine squared 3 pi over 4. Cosine squared is negative radical 2 over 2. Squared, of course. Sine squared is radical 2 over 2 squared, of course. This will be 2/4 minus 2/4, or if you prefer, 1/2 minus 1/2. Notice you are squaring a negative, so it turns positive. But this negative is outside of the parentheses, so this negative in the middle stays negative, and so your answer is 0. Now, you probably already knew that. It's 270 degrees. So mainly this is not, to have you solve something that you didn't already know the answer to. This is just to exercise the formula so that you get the idea of how it works. Mainly so that you believe that it's true, that you're not just memorizing some recipe. Okay. Let me do one more that might be a little bit more useful. Use the fact that sine of 7 pi over 6 is equal to negative 1/2 to find cosine of 7 pi over 3. This is the reason why we have the alternate versions. So use version 2. Cosine 2x is 1 minus 2 sine squared x. That was version 2, right? I want to look back and make sure that I got the right version 2. It is. It's the right one. But if you're not sure, then start with version 1 and then rearrange it until you get to this version. Okay. You might also want to make a mental note. 7 pi over 6. 7 pi over 6 is, what's that? That's 210 degrees. I don't know if you can do that with mental math. It's 7 pi over 6 times 180 over pi, which is 7 times 30, which is 210. The 6 goes into 180 30 times, so you just get 7 times 30. Yeah. 7 pi over 3 is 420 degrees. Again, 7 pi over 3, if you can do mental math, that's great. But if not, just know the formula to go from radians into degrees so that you can think about, what this angle is. You do want to make sure that they're actually double. This formula is no good if these are not double, if, this one is not double of the original x. So this is your original x, and this is your 2x. Okay. I'll leave that to you. I'll say DIY. For this one, you should get 420 degrees. Go ahead and try that. All right, in this example, I was only given sine, and I want to know cosine. So I'll use the formula. Cosine of 2 times 7 pi over 6 is equal to 1 minus 2 sine squared 7 pi over 6. So use the original x. The exponent comes outside the parentheses. Be very careful. And then replace that with negative 1/2. So you're going to get 1 minus 2/4. 2/4 is the same as 1/2. So your final answer is 1/2. And I hope that makes sense. If you think about the unit circle, 420 degrees would be like spiraling around one whole revolution plus an extra 60. That would be 420 degrees. And if you look at the triangle in the unit circle, it makes sense that cosine is 1/2. Check. The reference angle here is 60 degrees. It's like, imagine 360 plus an additional 60 degrees. Okay, so those are the double angle formulas for sine and cosine. Let's play around with those formulas before we do the half angle formulas. Let's do some more examples. Use the fact, or maybe not fact, I'll just say given. I mean, it is a fact, but it's not a well-known fact, so I don't want to call it that. I'll say given, I'm going to give you that tangent of x is 21/17, and we are in quadrant 1. So assume the terminal side of the angle is in quadrant 1. Find sine of 2x. Okay. So we're in quadrant 1. We know the tangent of x is 21/17. You don't know what the hypotenuse is. So you're going to use Pythagorean theorem. 17 squared plus 21 squared is equal to, let's call this, I don't know, c or something. These are getting a little out of my league here for squaring in my head. So 17 squared, oh, I knew that, 289. 21 squared, anybody know 21 squared off the top of their head? 441. So you get 730 is c squared. So we'll just say c is the square root of 730. It's not a perfect square. I don't even know if it's reducible. Let's just leave it as that. Might as well be exact. Okay. You can round if necessary. Or if instructed, I should say. If the instructions make it necessary that you round. Maybe I'll round at the end just to be safe. Okay. So now I've got my hypotenuse, square root 730. So now I know that sine x is 21 over the square root of 730. And cosine of x is 17 over the square root of 730. So therefore, sine of 2x is 2 sine x cosine x. That's my favorite formula. Of all these, this is my favorite. So you get sine and cosine. Just bring these down. Okay, the bottom's going to be easy. It's just going to be 730. The top is going to be 2 times 21 times 17, 714. Reduce this, 357 divided by 365. Can I go any further? These might be divisible by 3. Let's try to divide that by 3. Nope. So the denominator is divisible by 5. The numerator is divisible by 5 also, I think. Let's see. Oh, no, it's not. It ends in a 7. So we are done. This is the exact value. If you are instructed to round this to a decimal, you certainly can. So I'll just do it just to be safe. 357 divided by 365. So this would be approximately 0.9781 as a decimal. I actually prefer the exact. So, most of the questions that I ask for the exact. But occasionally there's some programming issues, and so I just go to a decimal because the computer likes it a little bit better. It's not necessarily what I like, but so I want you to be able to do both, either way. Okay. Suppose you're given that secant of x is equal to 20/3 in quadrant 1. We'll get out of quadrant 1 in a minute. Find cosine 2x. All right. This is essentially a free answer. Yeah. If I give you secant, I'm really just giving you cosine. Cosine is just the reciprocal of the secant. So all you do is flip it over. 20/3 becomes 3/20. So I'm essentially giving you cosine in disguise. Yeah. I would use version 3. Cosine double angle for version 3 was 2 cosine squared minus 1. Make sure you have it in the right order. I've made a million mistakes where I think I have the formula right, but it's backwards. So this is the correct order. If you have to look at your notes, look at your notes. All right, remember that this is the same as the cosine squared. And I already know the cosine. So the cosine is 3/20, 3/20. So that's 9/400 when you square it. And then minus 1. So that's 9/200 minus 1. Oh, I got off. You can't see me. 9/200 minus 1. I'm coming over here. And so that's going to be 9/200 minus 200/200. So the final answer is negative 191/200. And you might think, well, wait a minute. You said I was in quadrant 1. Well, x is in quadrant 1. When you double the x, it actually pops it over into quadrant 2. Yeah. And you can kind of tell this angle is, the secant is pretty big, yeah? Or you could think the cosine is very small. So just intuitively, if you think about what your answer means, this means that this angle was pretty close to 90 degrees. Right? If you really wanted to know what it was, you could, use your calculator to figure out what it is. 3 divided by 20, and then cosine inverse times 180 divided by pi, 81 degrees. I'm not asking that in this question. I just want you to have some intuition as to what you just did. So the original angle was about 81 degrees. So double that angle is about 162 and some change. So it makes sense that your answer is negative. Yeah. If you would have got a negative answer that didn't make sense, or if you would have gotten a positive answer that doesn't make sense, using a little bit of intuition about the size of the angle relative to their trigonometric ratios is an important skill. I mean, that's the whole reason why we have trigonometric ratios. It's so that we can better understand the angles. Right? You don't really understand an angle if you don't understand its trigonometric ratios. So that's it for sine and cosine for now. We'll come back to doing more of these. Let's move on to tangent. So what's the formula for tangent of 2x? Well, again, it's going to be tangent of x plus x, and you're going to use the sum formula. This was one we rarely ever used the other day. I would say most important are the sines and cosines if you had to memorize, and you can always reproduce tangent through some other method. Let's see if we can remember it. It was tangent x plus tangent x over 1 minus tan x tan x. Although last time we did this problem, this was an alpha, this was a beta. They were different angles, but today they're the same angle. They're both x. So we get our tangent formula. 2 tan x over 1 minus tan squared x. That wasn't so bad. So there you go. Now you've got all three formulas. I don't give formulas for cosecant, secant, and cotangent. Just use sine, cosine, and cotangent, and reciprocal. In other words, I'm not going to give you 6 formulas. I'm going to give you 3. And then if you want the other 3, you just take the first 3 that I gave you and flip them all upside down. Reciprocate. All right. So how about this? Given cosecant x is equal to 15 halves in quadrant 1, find tan 2x using this formula here. So I gave you cosecant, so you have sine is the reciprocal. You're in quadrant 1. Maybe I'll draw my picture a little bit more realistic. 15 is the hypotenuse and 2 is the adjacent. I'm not sure if it's become clear or not. When you do a reference triangle, the hypotenuse can be any size you want. It can be any size. If you use the unit circle, you have choices. The only main difference is the unit circle, the hypotenuse has to be 1. In which case, you would just put 2/15 as the actual length of this side right here. And I don't like doing it this way unless I absolutely have to. Mainly because, I mean, you'll get the same answer either way, but oh, it's so messy. It's so messy to have these fractions, 2/15 and so on and so forth, but you will get the same result. The main difference is the size of the triangle. I'm just going to use a reference triangle where the hypotenuse is 15. Okay. So use this reference triangle. What are we trying to find? We're trying to find b, I guess. So we have b squared plus 2 squared equals 15 squared. I don't want to call this side x because I'm already using x for the angle. Yeah, so x is technically right here inside the triangle, that little angle of x. You don't want to use x twice. You'll get confused and won't realize which x is which. Unless you're really clever and you write your x's differently so that you can tell which one's which. So you get b squared plus 4 is 225. I think I memorized that one. 15 squared. Do I have to use the calculator? I don't think so. So you're going to subtract b squared is 221. If you really want to be safe, 15 squared minus 4, 221. All right. And so b is the square root of 221. Give it a try. It might be a perfect square. Probably not. Nope. It's a decimal. So I'm just going to leave it unsimplified for now. When I'm done with the problem, I'll read the directions carefully and decide if I want to do exact value or rounded value. Okay, so now what do we know? We know that tangent of x is 2 over the square root of 221. Down here in the unit circle, it'll be much messier. It'd be 221 inside the square root, all divided by 15. And so to find the tangent using the unit circle, it's a little messier. To find the tangent using the reference triangle, you just use basic trigonometry. The tangent is, oh God, that's hard to read. The tangent is 2 divided by 221. In other words, the opposite over the adjacent. All right, we're ready to roll now. We got tan 2x is 2 tan x over 1 minus tan squared x. I like to get rid of the word tangent and put blank parentheses and put your exponent on the outside, and then now just insert the value of tangent. And simplify this as much as possible. That's 4 over the square root of 221 over, I'm getting kind of messy here, that's 1 over, now you're going to square the square root here, so that's going to be 4 over 221. So this numerator still has the radical, but the denominator doesn't. So now I've got 4 over the square root of 221 over 221 over 221 minus 4 over 221. I'm just rewriting my 1 as, so this is 1. So now I have 4 over the square root of 221 over 1, what is that, 17 over 221. Reciprocate, 4 over the square root of 221 times 221 over 117. So you're going to get 884 over 117 times the square root of 221. I don't know if you can simplify that. You can certainly try. 884 divided by 117. Sometimes you get lucky. Nope. They're not divisible by anything nice. Are they divisible by 3? Let's try 884 divided by 3. Nope. 117 is divisible by 3. You get 39, but 884 is not, fortunately. So that's your answer. You can approximate if needed. And what do I mean by needed? I mean the instructions are requiring you to approximate that. All right, let's get out of quadrant 1. We got to move around the unit circle and go to some of the other quadrants. Okay, so suppose you're given sine, and sine is a -5/13, and x is between 3 pi over 2 and pi. That means that it is between 180 degrees and 270 degrees, so this is quadrant 3. Yeah, so you're in the lower left quadrant. So this is where you're at. Yeah, here's 180. Here's 270. So we have an angle in quadrant 3. That's our angle x. So it's more than 180 degrees. Remember, all angles start in the positive axis. Yeah. initial point, technically 1, 0. Right. This is technically not called the x-axis anymore because x is the angle. So they have some fancy names for it, like the abscissa and the ordinate. But you could say what we used to call the x-axis. Okay, when I'm using x for an angle, I can't also use it for the axis. So I know that over here, I've got -5 is the opposite side, and 13 is the hypotenuse. So when you are given a sine or a cosine, the negative is always associated with the numerator. The denominator represents the hypotenuse. A hypotenuse can never be negative. All right. A hypotenuse is technically a radius. You're saying that this angle, if you started at the origin, has a radius of 13, because you're really thinking of this as a circle. All right. We call it trigonometry, but another name could be just as well circleometry. Just doesn't kind of ring off the tongue like trigonometry does. All right. So go ahead and find the missing side. You can call it whatever you want, but I wouldn't call it x. I call it A or B or C or whatever you want to call it. I chose A this time. So I've got a squared plus -5 squared equals 13 squared. Oh, shoot, I forgot to put down the question. Oops. The question is asking us for a tangent of 2x. Almost forgot to put down what the question is. So first I need to figure out what tangent of x is, so I'm going to find out what a is. So I've got a squared plus 25 is 169. And we might get lucky. Nice. Perfect square. If you get a perfect square, you don't need this. All right, this is unnecessary when you get a perfect square. So I know that a is, now be careful, when you use the square root, it's just going to tell you 12. All right, when you hit your square root button on your calculator, if you use your square root button, you don't really need it on this one. All right, so technically this is plus or minus depending on the quadrant. Yeah. So since we are in quadrant 3, both the cosine and the sine are negative. So we're going with negative the square root. So this is -12, and we need to be careful. All right, so we were given the sine. We were asked to find the tangent. So the tangent of x, not the double x, just the original x in my picture here, is -5 divided by -12, which is just positive 5/12. So now I can use my formula. Tan 2x is 2 tan x over 1 minus tan squared x. And I can easily finish the job here. 2 times 5/12 over 1 minus 5/12 squared. And now it's just fractional math. You can do that. You're going to get 5/6 over 1 minus 25 1/44. I know there's a lot of arrows here to follow. So now we're at 5/6 over 144 1/44 minus 25 1/44. 144 minus 25. Oh, it's not 121. What is it? 119? I feel silly having to do this. 144. My brain is tired. Yeah, 119. I just didn't trust myself. Now you're going to flip this sucker, so you get 5, 6, 144 19ths. I think 6 might go into 144. It should, because 12 goes into it. Yeah, you can simplify this a little bit. So you get 5 times 24 is 120 over 19. And that would be your answer. Exact. 120 over 19. My battery's about to die. Hold on a second. Plugged in. Okay. I think we have time for one more, and then I'm going to do the half angles tomorrow. All right, so let's do one more. Let's say we're given tangent of x is negative 1/3, and cosine of x is positive. This time I won't forget to put down the question. Find sine of 2x. I'll end with my favorite of all the double angle formulas. Sine of 2x. All right, so this time I didn't specifically tell you what quadrant we're in, so you're going to have to do a little investigating. Cosine is positive in quadrant 1 and quadrant 4. I almost wrote 3. 4 is IV. Yeah, quadrant 1 and quadrant 4, the cosine is positive. So I'm telling you it's got to be in one of these two quadrants. But I also told you tangent is negative. Tangent is negative in quadrant 4 and in quadrant 2. So by using a little deductive reasoning, I'm telling you it's in quadrant 1 or 4, so it can't be in quadrant 2. And I'm telling you the tangent's negative, so it can't be in quadrant 1. And so in other words, these two things together narrow it down. I know that I'm in quadrant 4 now. All right. That's super important, because if you just try to solve the problem, ignoring all of the fine details about, positives and negatives and what quadrant you're in, you're going to get the wrong answer. Really, you are. I mean, very rarely can you ignore these details and just pull it off. Woo, I got lucky. Once in a while you might dodge a bullet, but most of the time you end up getting the wrong answer. All right, so now that we've resolved that, we know that we're in quadrant 4. We know the tangent. So there's our angle in quadrant 4. I'm just going to go ahead and write it as negative 1. So the numerator and then the denominator is 3. Remember, tangent is the same as slope. So you don't know what the hypotenuse is. But you can find it out very quickly. Just use Pythagorean theorem, solve for c. So c is the square root of 10. Okay. And this is my favorite formula. It's the one that you're going to use a lot in calculus. I mean, I'm sure you'll use all of them, but this is the one that comes up quite a bit. This is the one that you just need to know as soon as you see it. The other ones, you think about it, you dig a little bit, you do a little manipulation, but this one is right out of the can. It's a canned answer here. All right, so look at this triangle here. I know that c is square root of 10. Yeah, so the sine of this angle is negative 1 over square root of 10. That's the sine. The cosine is 3 over the square root of 10. So your final answer is negative 6 over 10, but I want you to reduce it to negative 3/5. And that's it. So that concludes the double angle formulas for sine, cosine, and tangent with some various instructional differences. Pay attention to the quadrants. And my next lecture will be the half angle formulas. Dr. Jordan, signing out.